All right, so here's an example where we're going to start with a graph and try to come up with the function that represents this graph, okay? Remember that anytime you have a sine or cosine, and my formula here works for both sine and cosine, the constant that's being added or subtracted is your vertical shift. The absolute value of the coefficient here is going to be your amplitude. 2 pi over the b is going to be your period, again, when this is in factored form. D is the phase shift when it's in factored form, the argument. And if the a value were to be negative, there would be a vertical reflection. What I want to point out, though, as we do this, is that this graph can be represented by actually an infinite number of different functions. Okay, so there's not just one correct answer here, there's many correct answers. There are some that are a little bit more obvious than others, but you can phase shift, you can start at any point along here. You could use sine or cosine, depending upon where you phase shift, as long as everything is consistent. So if you're going to use a cosine, you need to make sure to start at a maximum. If you're going to use a negative with your cosine, you need to start at a minimum. And if you're going to start with a sine, you need to start in the middle somewhere, okay? So that's the main thing. Everything has to be consistent. Once you pick one, everything builds off of that. There's a few things that we can determine right away, though. The period is probably the first thing. The period does not matter whether it's sine or cosine. It's kind of independent of those. And so here I'm looking at this, and for the period, you always want to go from, take a point and then on the graph, and then go to the symmetric or a similar point on the wavelength. So you could go minimum to minimum, middle to middle. You always have to skip a middle because there's 3 middles on a wavelength, and then, or you could go, top to top, which I only have one top, so I'm not going to do that. I'm actually going to go with maybe the bottom to bottom here. And so I know that one period is mapped out between 7 pi over 3 and negative 5 pi over 3. I don't know if you can read all these. My units here are pi over 3. So there's pi over 3, 2 pi over 3, pi, 4 pi over 3, and so forth. And same in the negative direction. In the y direction, I have 1, 2, 3, 4, negative 1, and negative 2. Okay, so I'm just looking at my period right now. The period is going to run from 7 pi over 3 to negative 5 pi over 3. And if I subtract those two values, I will get the period. Well, of course, the double negative makes for a positive or a plus. So it's 7 pi over 3 plus 5 pi over 3, which is 12 pi over 3, which reduces to 4 pi. So that works out nicely. It's a 4 pi period. Okay? So if the period is 4 pi, and I know that the period is equal to 2 pi over b, I can find my b value by equating those two expressions. So I take 2 pi over b equals 4 pi and solve for b. Solving for b, I'm going to multiply both sides by b. That cancels the b on the left. I get 2 pi equals 4 pi b. And then I divide both sides by the 4 pi. That cancels the 4 and the pi off the right. Also cancels the pi off the left. And 2 over 4 is a half. So that means my b value is a half. So when I get to constructing this equation, I'm going to put a 1/2 in for the b value. All right. So now I've got to determine, there's one other thing that doesn't matter whether it's sine or cosine, it's the vertical shift. So the vertical shift, and the amplitude really, the vertical shift is obviously 1 because the central axis here is 1 unit above the x-axis. So vertical shift is 1. So that tells me that the c value is going to be 1 no matter what I use here. And what else do I need? The amplitude, obviously from 1 to 3 or 1 to negative 1 is a value, a difference of 2. So the amplitude is 2, or it could be -2 depending upon whether we want to have a reflection or not, okay? So amplitude, absolute value of A is going to equal 2. So whether we use A to be plus or minus 2 will depend upon whether we use sine or cosine and what we want the phase shift to be. And so here I'm going to go ahead and write this out using a, I don't know, maybe using a sine. Again, it doesn't really matter. If I choose sine, I've got to start at the middle. If I choose cosine, I have to start either the top or the bottom. And the sine, I could really start either of the middle for my phase shift. So I'm going to go ahead and use sine. And I'm going to start at this left middle point as my starting point for the sine. So that would give me my phase shift. So because I'm just designating that, and I could have, of course, I could choose something different as long as everything is consistent from here on out. So I'm going to choose sine. You don't have to, but I could here. I'm going to here. And I'm going to choose a phase shift. And phase shift of, let's see, that'd be a -2 pi over 3. Okay, with a phase shift of -2 pi over 3. And because this graph from that point goes up, I don't need a vertical reflection, so I'm going to choose the positive on the amplitude. Okay, if this graph had gone down, or if I had chosen to phase shift 4 pi over 3, I would need a negative on my 2 because it'd be starting going down. That would be my reflection. Okay. Okay, now with all of this in mind, I should be able to just piece everything together into the equation. So I'd have y equals, now the c value is first. I'm going to put a 1 in there for c. I said I'm going to use a positive for the a, so +2. We're going to go with a sine. Now my argument is going to be in factored form. I want the b value, which we found over here, to be 1/2. And then I want x minus the phase shift. So this would be x minus, well, this is a -2 pi over 3. When you do the minus of a negative, it becomes plus. So this is actually plus 2 pi over 3. All right? Yeah, that should give us our function. That would be a correct answer. You could distribute the 1/2, but you wouldn't need to. So I would just leave it in this form. It makes things a little bit more clear, especially for me as I'm grading them. I would just leave it in this factored form. For my sake, it doesn't make it easier for me to grade them. Again, there are other functions I could have used if I had chosen to go with a cosine, for instance. Maybe I'll run through this one time with a cosine. If I had chosen to use, let's go with a cosine, maybe starting over here on the far left, then this minimum, because cosine starting at a minimum would be a reflection, I would go with a -2 for my amplitude, because it'd have to flip over to go from the top to the bottom. And then the phase shift would be different. The phase shift would be at -5 pi over 3. So I would use a cosine. I'd still have the 1/2 for the b value, but then I would have x plus 5 pi over 3 as the phase shift. Yeah. Okay, so there's, like I said, there's an infinite number of ways to, or infinite number of equations we can use. I just found 2 of them here. They're all correct as long as they're consistent. Your 1 and your 1/2, 1 and 1/2 are going to be the same no matter what you choose. It's just and the 2 is going to be the same. So the only thing that really changes are going to be whether the 2 is positive or negative, the amplitude there, whether using the sine or the cosine, and what the phase shift is. Okay, so those are the three things that could change depending upon where you choose your starting point to be and which function you use, sine or cosine. Okay, so those are the two things you choose, sine or cosine, and where your starting point is, your phase shift. All right. Okay, hopefully that helps you to determine that. Again, there's an infinite number of possible answers here. I think when you do this on my math lab, if I'm not mistaken, it will tell you whether to use sine or cosine, and it will tell you where to start using your phase shift. Okay, so if it gives you that information, then there's really only one possible answer. Otherwise, you could choose those two pieces of information and get really any number of things.